So let's have a look at covalent bonds. So covalent bonds are formed when two non-metal atoms share pairs of electrons. Covalent bonds are strong because the shared electrons are attracted to the nucleus of both atoms. And covalently bonded substances can be small molecules like water, or they can be large molecules like polymers such as polyester or silk, or they can be called what we call giant covalent structures, like diamond would be an example of one. So let's recap a little bit of that. What do we call the bonds that form when non-metal atoms share pairs of electrons? Well, that's covalent bonds. That's what we've just been talking about. And covalent bonds are formed when two non-metal atoms share pairs of electrons. So an example of that might be in the gas hydrogen, H2. Each hydrogen atom brings one electron and they share both of them in the middle, and it allows them to both have a full outer shell, and it's shared between the two of them. Now you can also look at metallic bonding. So metallic bonds are the electrostatic attractions between positive ions and negative delocalized electrons. So metals are made of giant structures of regularly arranged atoms. And the structure is a regular lattice of positive ions, which we also know as cations, and a sea of delocalized electrons. What I mean by a regular lattice is it's in like a grid structure, so everything's lined up, all the atoms are lined up together. And the delocalized electrons are not bound to any single atom, and they're free to move anywhere within the lattice. And that delocalization happens because metal atoms have a small number of electrons in their outer shell. So what's the name for the positive ions? Now remember, they are called cations. And in metals, what do electrostatic attractions form between? So metal ions, number one, the cations, and the delocalized electrons. And the types of covalently bonded substances, remember we've got small molecules like water, we've got large molecules like polymers, and we've got giant covalent structures like diamond. And in metallic structures, they consist of a regular lattice with positive ions, which are called cations, within a sea of delocalized electrons, which are free to move throughout the structure. Which of the following would metallic bonding be found in? So metallic bonding would be found in sodium, but it wouldn't be found in sodium chloride. That's ionic bonding would be found there because it's a mixture of a metal and a non-metal. Magnesium oxide, for the same reason, it's a mixture between a metal and a non-metal, so you wouldn't find that there. Find metallic bonding there, but you would find it in magnesium. And the last place you'd find metallic bonding is within alloys. So brass, for example, is a mixture between copper and zinc, and that's what an alloy is. And covalent bonds are strong because of the shared electrons are attracted to the nucleus of both atoms.